Hello, I'm Lynn Bondran, and welcome once again to our series about America's civilian efforts in air and space during a quarter century. This is our last program in the 25 Years of Progress series, and we cover some of the NASA events of 1983. In early 1983, NASA launches a satellite which is able to observe heavenly bodies in the infrared.
Late last year, the Infrared Astronomical Satellite underwent final system testing at NASA's Jet Propulsion Laboratory in California. IRAS, as it is called, is an international project that includes NASA, the Netherlands, and the United Kingdom. The heart of this new Earth-orbiting satellite is a highly sophisticated infrared telescope, supercooled to 455 degrees below zero, giving it unprecedented sensitivity to celestial infrared radiation. Recently, IRAS was launched into orbit above the Earth's atmosphere by a Delta rocket. Over the course of its projected 7-month mission, IRAS will scan the skies at 4 different infrared wavelengths, detecting possibly 1 million celestial phenomena that are invisible to our eyes but glow in the infrared. One such phenomenon is the birth and death of stars. IRAS project manager Gerald Smith explained.
We believe that stars are formed from dust clouds, which are condensed from very low temperature dust in the sky. And this low temperature dust gives off light in the infrared, and so the infrared is the best tool for looking at that formation process. Also, after stars have died and have collapsed, again they reach a fairly cool temperature, and again infrared is one of the best tools for looking at that process.
The Infrared Astronomical Satellite, looking at the skies in another light to help astronomers better understand the evolution of the universe. Over the past few years, there has been an unusual amount of volcanic activity on Earth, including Mount St. Helens in 1980. At least 5 of these eruptions have poured more than 1 million tons of volcanic debris into the upper atmosphere, keeping scientists at NASA's Ames Research Center in California busy trying to determine the potential effects of these volcanic clouds on our environment. One such scientist is Dr. Brian Toon.
Well, what we're interested in is how volcanic eruptions may affect the climate. And it is observed whenever you have a really large eruption that adverse weather does occur in the year after that eruption. So we want to understand, why does the bad weather occur? What is it about the volcanic debris in the stratosphere that causes these effects on the climate? We want to understand this well enough so that we can predict not only for volcanoes if they're going to affect the climate, but also for other things that may put particles into the upper atmosphere, whether they'll affect the climate. For example, flying rockets through the upper atmosphere or flying aircraft in the upper atmosphere. We want to know whether any of those things are going to have a serious effect on the climate by putting up particles the way volcanoes do.
A NASA U-2, one of the few aircraft in the world capable of flying into these volcanic clouds some 10+ miles above the Earth's surface, has been equipped with a variety of sample-gathering instruments, including a series of tiny external wires which collect debris as the air rushes past. After a flight, these wires are carefully transferred to a scanning electron microscope and magnified up to 30,000 times to help determine the chemical makeup of the cloud. NASA's volcanic cloud studies, looking at the atmospheric debris generated by these natural events so that we can better understand their impact on our environment.
A NASA probe is the first man-made thing to leave the solar system.
Launched in 1972, NASA's Pioneer 10 spacecraft has accomplished many firsts over the course of its 11-year space odyssey. One was a successful passage through the rocky asteroid belt, a feat which greatly alleviated the fears of scientists concerned about damage to far-traveling spacecraft. Having safely journeyed the some 2.5 billion miles to Jupiter, Pioneer 10 transmitted valuable scientific information back to Earth, information shedding new light on the composition and evolution of Jupiter and its moons. On June 13th of this year, Pioneer 10 will travel beyond all the known planets and become the first man-made object to leave the solar system. As NASA's Deep Space Network continues to track the spacecraft out to around 5 billion miles, researchers hope to learn more about the boundary between the Sun's atmosphere and true interstellar space. Pioneer 10, a spacecraft that has journeyed further than any other to the outer planets, and now beyond our solar system. A man-made object which will, from a new vantage point, in Whitman's words, look up in perfect silence at the stars. It's called ET, space shorthand for external tank. Over the past 2 years, several of these 78,000-pound structures, towering like huge silos over the shuttle orbiters and solid rocket boosters they support, have successfully carried the 520,000 gallons of liquid hydrogen and oxygen necessary to power the shuttle's 3 main engines. Although they have performed flawlessly, providing fuel up to about 80 miles above Earth's surface, then disintegrating upon re-entry, their structural design has been under study for some time now. Late last summer, a significantly lighter version was completed and rolled out at the Marshall Space Flight Center's Michoud Assembly Facility in New Orleans. By reducing the weight of the tank some 8,000 pounds, the shuttle will be able to carry an additional 8,000 pounds of cargo into space. One obvious weight reduction measure was taken before the third shuttle flight, when 600 pounds of white latex paint used previously on the tank's outer surfaces was eliminated after data from the first 2 missions indicated that its thermal system would provide adequate protection without the paint. The most recent modifications include the use of thinner aluminum skin panels. A number of structural stiffeners running the length of the tank have also been eliminated. Once assembled, it's loaded aboard a NASA barge and shipped to the Kennedy Space Center, Florida, to be prepared for flight. While the first lightweight tank was used on Shuttle Mission 6, similar ones have either already been delivered or are in the process of being assembled by the Martin Marietta Corporation for shuttle flights 8 through 19. Although the external tank is currently the only major element of the shuttle not recovered, it is conceivable that at some future time, a properly designed tank could be used to carry additional cargo into space, or that several redesigned tanks could be linked together to form the nucleus of an Earth-orbiting space station. NASA's new ET, a lightweight external fuel tank that trims away unnecessary pounds, making it possible to increase the cargo carrying capacity of the space shuttle.
Bring the camera down so that we don't get quite so much background in there. You can see more in the payload bay.
The second space shuttle, Challenger, makes its maiden flight and is prepared for its second space flight in June 1983.
2, 1, 0, and liftoff. Liftoff of the orbiter Challenger and the 6th flight of the space shuttle. The shuttle
1:30
has
p.m.
cleared the
April
tower.
4th marked the beginning of Challenger's first flight when the new orbiter lifted off without a hitch from the Kennedy Space Center, Florida. In its payload bay was the first tracking and data relay satellite, or TDRS-A. The satellite was deployed from the bay by a spring-powered mechanism.
There it goes, straight out. Neat. Look at that, baby.
The first spacewalk, or extravehicular activity, in connection with a shuttle mission took place on the 4th and 5th days of the flight, as mission specialists Story Musgrave and Donald Peterson became the first American astronauts in 9 years to walk in space.
We got a pretty bad ring here, and we're wondering if you troubleshoot it for us. How's that compare to the one?
The EVA consisted of exercises to determine the mobility of their spacesuits, as well as experiments in handling and evaluating workstations and tools to prepare for satellite repair work scheduled next year.
Story, you're aware of where your safety tether is.
The astronauts also spent time monitoring various experiments, including 2 flown on previous shuttle flights. The continuous flow electrophoresis system that takes advantage of the weightless environment of space to separate materials with greater purity than is possible on Earth, and the monodisperse latex reactor, which produces microscopic latex spheres for use in medical applications. The crew also gathered information on lightning associated with earthly thunderstorms visible beneath Challenger's flight path. After 5 days, 80 orbits, and 2.2 million miles in space, Challenger completed its maiden voyage with a perfect landing near the Mojave Desert in California, April 9th. Challenger is now prepared for its second flight, Shuttle Mission 7, with launch scheduled for June 18th. The spacecraft looks much like its sister orbiter Columbia. The two are about the same size, but Challenger's lighter, stronger construction, together with its more powerful engines, enabled the new orbiter to carry more than 15,000 additional pounds of payload. Mission 7 will, for the first time, utilize a 5-member team of astronauts, including the first American woman to fly in space, Sally Ride of Encino, California. She described her experience as a female in a traditionally all-male profession.
I think that once NASA made the decision that they were going to bring women astronauts into the program, they made that decision and stuck by it, and NASA was well prepared for us when we came, I think, for the most part. They treated us the same as they did the men. Our training has been no different, either in the physical side of it or in the actual assignments that were given, the tasks that were assigned, the flight assignments. I really don't think there's been any distinction between the women astronauts and the men astronauts. So from that point of view, it really hasn't been hard at all.
Commander Bob Crippen of Beaumont, Texas, has flown the shuttle once before as the pilot of STS-1.
T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine.
That first mission was a test flight to evaluate and verify the shuttle system's performance. The Space Transportation System is now in business or fully operational, ready to carry a variety of payloads. Commander Crippen explained.
The space shuttle is for hire. We're really a large space truck, and anybody that wants to put a satellite up and puts the price of going up, we're prepared to carry. The space shuttle is also booked up for several years ahead with satellites to carry, and some of them are foreign, some of them are domestic. The only other way of putting up satellites, of course, is with expendable boosters, and we think that the space shuttle provides a more economical and probably a more reliable means of putting up satellites, and the business is out there, and we're ready to carry it.
Mission Specialist John Fabian of Pullman, Washington, described the basic purpose of the flight.
There are several mission objectives for STS-7, and our principal role will be to deploy 2 telecommunication satellites, the Telesat telecommunication satellite for Canada and the Palapa satellite for Indonesia. In addition to those 2 principal roles, we will be carrying on a series of experiments using the German SPAS-01 satellite, which we will also deploy into free orbit and subsequently retrieve with the space shuttle, and thus check out the shuttle's capability to retrieve satellites from orbit and return them to Earth. 2 telecommunication satellites are attached to what we call PAMs, which are payload assist modules. The PAMs are attached to a rotating table, which in turn is fixed into the cargo bay. We spin up that table, give the payload a rotation, and then at the proper time, springs actuate the spacecraft and push it up out of the bay, so it comes up out of the payload bay, spinning with about 6,000 pounds of force behind it from the springs. The payload assist modules carry with them a solid rocket motor, which can be used post-deployment from the orbiter to boost the satellite into an orbit which is 22,000 miles above the center of the Earth.
Okay, we see fan A on, and we'd like you to take
For the
Bravo
first time, the shuttle is to use its remote manipulator system, or robot arm, to deploy and retrieve a payload. A West German Pallet satellite, SPAS-1, will perform experiments in space near the orbiting Challenger before being retrieved. Sally Ride, mission specialist, explained the process.
We're going to use the RMS, the arm, grapple a payload that's in the bay, the SPAS-01, which is a German-made pallet, deploy it, let go of it, make it a free flyer, and then Crip and Rick are going to fly the orbiter away from it. Well, John and I control the SPAS from inside the orbiter, and then they'll fly the orbiter back up to it, and either John or I will use the arm to re-grapple the payload and then put it back down into the payload bay and demonstrate the orbiter's ability to grab a satellite that is a free flyer in orbit and bring it back to Earth.
The pilot for Space Shuttle 7 will be Rick Houck of Winchester, Massachusetts and Washington, D.C.
I'll be primarily concerned with the photographic and TV documentation of the tasks that we do on orbit. I'll also be concerned with the managing of the majority of the orbiter systems. Of course, Bob Crippen is the commander and will sit in the left seat and conduct the virtually all of the flying tasks that are required during launch and landing. I'll be in the right seat as the pilot, what most people would call the co-pilot of the aircraft. I'll also be responsible for opening the payload bay doors once we get on orbit and closing them prior to coming home. And we'll all share in the housekeeping tasks. As the days progress, we'll each have our turn at preparing meals and cleaning up the house and making sure that the mundane requirements of space flight are accomplished, keeping the vehicle shipshape, if you will.
STS-7 will be the first shuttle flight to land at the Kennedy Space Center, Florida. Previous shuttle missions have landed in California or alternate facilities in the western U.S. Pilot Houck explained the advantage of landing the spacecraft at Kennedy.
The landing at the Cape at Kennedy Space Center is important to the program in that the time required to ferry the space shuttle back to the Cape is then deleted. So in the long run, it's very important to the program, since we are a scheduled airline, if you will, to minimize delays in the turnaround of the vehicle. And by landing at the Cape, all that is required to get Challenger back into the processing facility is to make a very short, about 1.5 mile tow on the ground from the landing facility over to the processing facility.
Dr. Norman Thagard is the third mission specialist. As a medical doctor on board, his main responsibility is to study and conduct experiments relating to space motion sickness, or space adaptation syndrome, which affects about half of the astronauts who have flown on the shuttle.
You're probably aware of the incidents we've had of people with space adaptation syndrome. We now call it space motion sickness, if you like. It's the syndrome in which anywhere from 1 to 3 days in flight, people begin to feel a little malaise, a little below the weather, and some people have even thrown up. And we have decided that we'd like to have a medical doctor on board to study those things, and that's my job for STS-7. Mostly the things I do are a continuation of some tests that have started 1 or 2 flights ago. There is one aspect of it that hasn't been done before. This will be the first time that we've actually flown a medical doctor to look at the problem. So if anyone is sick and that person is not me, at least we'll have the opportunity to have a physician look at the affected people, do a brief physical exam.
Other experiments on board Challenger include 7 small self-contained payloads, or getaway specials, which are available to private industry, educational organizations, and domestic and foreign governments.
Well, a getaway special is kind of an economy plan experiment which can be conducted in space and attached to the space shuttle. They can be activated by the crew from the aft cockpit, and they are contained in large gas cans which look something like a 50-gallon drum. They carry their own electronics, their own power supplies, but can receive signals from inside the space shuttle. And there are a wide variety of experiments of this type which have flown and which will fly in the future on the space shuttle.
The opportunity to fly in space is a personal goal of all the astronauts. It is the culmination of extensive training and hard work.
45 at the lower rate.
Control cable, we've got that, and DC utility power off.
I'm looking at you.
That's close enough.
You can come just down a little bit.
Down a little.
Perfect.
I would like to fly it 6, 8, 10 dozen times, given my choice. It's especially a very challenging flight, and everybody likes to take a challenge and go out and try to do it well. I've got a super crew to work with, and I think we'll be able to conduct the mission as we planned it.
It's been many, many years that I've been looking forward to this, and I think it'll be the fruition of a lot of hard work and dreams I've had for a long time.
Personally, it's the culmination of a lifelong desire, dream. I've wanted to do this ever since I can remember. I read science fiction when I was a kid and always hoped that I could become an astronaut, never really thinking I had a chance, but knowing that if NASA ever took applications and I felt I had a chance, I would apply. So this is the end of a long road of hope and dreaming.
It means an opportunity, I think, to contribute to something that has always been important to me. I think it's a part of the future of the nation, and the opportunity to be a part of that, I think, is something that I'm very proud of.
I think it's just a great opportunity to do something that I've wanted to do for the last 6 years at least, since I've been at NASA. It's what the last 6 years have been pointing toward, and I think it's the reason that all the astronauts enter the astronaut program is a chance to get into space, and I'm really looking forward to that opportunity.
STS-7, Space Shuttle Challenger's second flight and the third operational mission of this country's space transportation system.
Meanwhile, NASA continues to work with new methods of informing the public about scientific and engineering information gained by the agency.
It's one small step for man, one giant leap for mankind.
For 25 years, NASA has documented its manned and unmanned space missions, taking literally hundreds of thousands of photographs. We have become familiar with images of our exploration of the solar system and beyond. Photography plays an important role in research, from aircraft performance in wind tunnels to close-up views of the space shuttle's engines at ignition. Although these pictures are a valuable resource, they take rooms to store, are costly to duplicate, and time-consuming to search. In an effort to increase accessibility, save space, and reduce expense, NASA is placing some of these images on video discs. This new technology can store over 100,000 pictures on a disc about the size of a phonograph record. The images are played back on a television and can be quickly scanned or studied one at a time. Planetary Data Management Team Leader at the Jet Propulsion Laboratory is Mike Martin.
This is a video disc. 54,000 separate images can be stored on each side of the disc. We're using video disc in the Planetary Image Facility to store our archives of images. The total archive is approximately 200,000 images, and we intend to be able to put that entire set on 2 video discs. You can see some of the binders in this room. We can put as many pictures on 2 sides of 1 video disc as are stored in this entire library.
The main advantage of the video disc system is that it allows the user to view thousands of images very quickly, compared to the slow process of leafing through volumes of binders to locate a particular picture.
A further benefit is that once the video disc is produced, the cost of replication is very inexpensive, $20 per disc. What that means is for $20, any college or any library, any high school in America that has a video disc player can have a complete archive of all the planetary images that exist. And that's one of our major goals, to be able to use this system to disseminate data so that everybody can study it and analyze it.
These are pictures of Mars taken by the Viking spacecraft and played through a video disc system. Dr. David Pieri, senior scientist at the Jet Propulsion Laboratory, has been studying the last group of Viking pictures.
They're probably some of the best pictures of the whole mission. The atmosphere was very clear, and we started to see areas on Mars which we had not seen well before, particularly the northern heavily cratered terrain.
Photographs increase our knowledge of Mars and provide evidence that water once existed on this now arid planet. Dr. Pieri explained.
Mars is like an onion. That is, each time you peel back a layer, you see new things. Each time we get a higher level of resolution, we see Mars becomes a different planet. Now we have very high resolution pictures of this, as I said before, the northern heavily cratered terrain. We see very complex valley systems. We see complex shapes, morphology, if you will, in the interiors of large channels, which may have been the result of large outpourings of water in the Martian past. And it is this type of feature which is perhaps some of the most compelling and convincing evidence for the flow of free liquid water across Mars.
NASA's photography, using video discs to increase accessibility and efficiency in space exploration and aeronautics research.
That concludes our 13-program series, 25 Years of Progress, which covers NASA history since the agency's birth in October 1958. Thank you for joining us. I'm Lynn Bondurant.
Roger, Columbia on a roll. Columbia, Houston, you're go at 40.
Roger, go at 40.